present my thoughts on inter-process communication along with side my partner Afaq Ahmed. So the question is, what is inter-process communication? Inter-process communication communicates refers to the methods used by operating system to enable communication and data sharing between different processes running on a same or different computer. Processes or instances is what are processes? Processes are the instances of a programs that are being run on a same computer memory. In the small processes system, the processes may now will tell you about the examples of the interprocess communication. For example, uh, if our two programs are running on a same way, an audio player and a video player. So the video player will make the frames of video and that it will share it within a shared memory. From there, the audio player will I can read that video frames and they will use it to synchronize the audio with it. Now I will tell you the second example of the interprocess communication. The second example is the chat application where multiple people can send or receive the messages. How they do it? When a user sends a message, it will put in a queue and the message will be received when the first message will be sent. That's how they did it. Now I will tell you why we need the inter-process communications. Inter-process communication. The need of inter-process communication are that IPC allows different software components and processes that work together simultaneously to possibly create and compile different advanced softwares. There are also that shared memory. They the shared memory. We need to share some memory due to the lack of main memory, maybe due to the lack of hard drive. We need to share memory alongside with others processes. And also we also used to need pipes and sockets. The pipes and sockets are the connections between the internal parts of a computer that they allow them to share to each other. Now I will like to call Afaq to tell about the programs.
Assalamualaikum. My name is Faq Ahmed and my registration number is 83. And I will tell you about three different programs using sockets, pipes, and shared memory interprocess communications. Now, our first programs tell us that how communication is possible using shared memory. In shared memory, we conserve as a memory address to do two different processes in which the two processes can access the same portion of memory. Now, if we see our first program, at first we declare the size of the memory which we want to we want for inter-process communication, and in the second line we give the memory a name, and in the third we write the message which we want to share between the processes. Now, next the SHM get command is used to allocate the memory to the processes, and in the first we give the IPC private which tells us that we want that the name of the type of communication. Then we give the shared memory size, and then we can give the user permissions which are read and write permissions. And IPC creates the process creates the memory. IPC Excel checks if a memory with the same name exists, then it does not make the memory. And the IR user allows the user to read the message, and IW user allows the user to write a message to the memory. Now we declare a pointer which with shmat command. The shmat command is used to write the message to the memory segment, and now the message we copy the message in the shared memory pointer, and the message is printed in the form. Now we will show you the output of the following program. Now you can see the output of the program. Now moving on to the next program, we use the message passing interprocess communication. Now, our next program is about interprocess communication using message passing. At first, we can see that we give our message queue a key which is 1234. In the next, we declare a variable of type 1. Then we write the message to which we have to share between the processes. Now, moving on next, we make the process using msget message queue key, where we give the message queue key, and IPC creates the message, and 066 are the user permissions which give the permissions to all users that they can read and write the file. Now moving on next, we declare the buffer size which is 1024 bytes. Now strc copies the message into the buffer, and the message buffer is the address of the where message is to be copied, and the message text is the text we want to share between the processes. MS message send is used to send the message to the processor to the buffer which writes the message on it. Message and next we print the message that we have sent to the next we print the message we have sent to the buffer, and in the next command we see that we copy the message in another we copy the message in another variable, and then we display the message again. Now the message ctl command is used to remove the buffer from the memory, and this is the output of the program. Now moving on to the third program, we will discuss inter-process communication using pipes. Now in the program we can see that we declare a pipe variable. If we declare an integer array with name pipefd, then we create the PID variable which will store the parent ID of the parent process, and chat buffer declares the how much memory will occupy in the memory, how much memory will be occupied in the RAM. The size of this buffer will be in bytes. It means the buffer of 50 bytes is created. Then we use the pipe command to create the pipe to make the variable declared in integer type a pipe, and then we use the for command to create parent and child processes. At first, the child parent process is executing. Then we know that the parent process ID is always greater than 0 and the child process ID is 0. Therefore, in the parent process, the else command will be executed. In the else command, we copy the message into the we copy the message hello world into the buffer and give its length, and then we close the connection to the pipe. Then when the parent process is executed, then we move to the same program is executed again, and now the PID is 0 because of the child, because the process is now child process. Then here we can see that we read the now here we can see that we read the message from the buffer which our parent process has sent to the buffer, and now the child process and copy it into a variable in the child process, and then we display the message in the child in the child process.
So, so the output of the program is here that has been explained by my partner Afaq Ahmed. Now moving toward the conclusion of the IPS, that there are different types of the IPS that we have seen in programs. The one is shared memory, the second is message passing, and third is pipes. And now we'll tell you the conclusions and main differences in between them. That in simple word, each IPC has its own strengths and weakness, and the choice of mechanism depend on the specific requirements of the applications. Shared memory is suitable for high performance application where processes need to be shared among large data large type of data, while message passing is suitable for flexible and reliable communication between untrusted processes, and pipes are suitable for simple and straightforward communication between processes. And this is all from us. Peace out.